Okay, everyone. Thanks for joining our session today. And we're very excited to have Todd Little from Oracle join us for a presentation about the Oracle blockchain platform. And we're going to make this really a great interactive discussion with Todd today. So anyone who has any questions, I want you to feel free to post them in the chat. And I know we also have people that'll be joining us on YouTube Live as well. So feel free to post questions there and we'll get to them right away. But at this point, I'd like to just kind of jump in a little bit and introduce Todd. So Todd has been really a great contributor to Hyperledger over many years. And he's currently the chief architect for the Oracle Blockchain Cloud Service. And that cloud service was released initially back in July of 2018. And he's responsible for the overall architecture and security for the service. And he's definitely been a high contributor in the Hyperledger community. And he's contributed in the privacy and confidentiality working group, as well as a great contributor to the performance and scale working group as well. And Todd, today I want to get in and really talk about performance and scale as far as one of the questions I'll have today. And then, Todd is also the chief architect for Tuxedo in the Oracle Fusion Middleware Development Organization, and really defining the technical strategy and direction for the Tuxedo product family. So at this point, I'm going to kind of turn it over to Todd a little bit here. And Todd, maybe you want to give an overview of some of your background and give, some insight as to your work with the Hyperledger framework.
All right, surely. Thanks, John. Appreciate the introduction. So yeah, I've been in this business for a long time. I won't indicate how many years, but you can tell from the gray it's been a few. So I've been working with Tuxedo since 1997. I was acquired from Digital Equipment by BEA Systems, and then Oracle acquired BEA Systems in 2008. So I've just been sort of getting dragged along. And so Tuxedo, if you're not familiar with that, is a transaction processing monitor and platform. It's probably one of the most scalable, high-performant transaction processing platforms in the world. And then our group in 2016 or 17 got this idea about what other transaction models are there. And so blockchain basically comes into that area, sort of transaction processing. So we decided we should create a blockchain offering. We made a proposal to our management, got shot down because I think they thought it was Bitcoin. And because that's what everybody thought blockchain was. Bitcoin and blockchain were basically identical. So anyway, it took a year before we were able to then get a go ahead. And so we spent 2017 building our platform on Hyperledger Fabric, and we've been enhancing that ever since. So what I want to talk about today is a little bit about our product and our offerings, and as well some of the enhancements we've been making to Hyperledger Fabric, both directly to Fabric code as well as to tools and stuff like that we've built, something we call the Blockchain App Builder. So with that, why don't I get started here and we'll get going.
Perfect.
You see my screen okay?
Everything looks perfect, Todd.
Okay, all right. Good. So what I'm going to cover, if I get my mouse over here, is I want to first cover a little bit about what our blockchain offerings are. So we have several different products in the blockchain space, and then I'll talk very briefly about some customer adoption, some of our partner solutions. And then largely, I'm going to spend most of the time on sort of the updates that we've made and some of the more recent changes that we've added to our service. And then finally, a Q&A session. So our vision is that we want to make blockchain available for enterprises, organizations, easy and quick for them to be able to build, deploy, and run, basically manage their applications and their blockchain applications. We see blockchain as being relatively pervasive. Many industries, all of our verticals are looking at blockchain solutions. So we're working with a number of different partners. We're working with our own internal SaaS organizations. Sort of what the Fusion apps and their interest in blockchain. I'll talk a little bit about some of the work they've done to integrate in with our blockchain service into their SaaS offerings. And our strategy basically is to make it quick and easy. We want to build a market-leading platform for blockchain adoption. And we also recognize that people want to do this both in the cloud, but they also need to do it on premise. I mean, Oracle has a large number of regions for our cloud offering, but we're not in every country. We'll probably never be in every country, at least with a separate data center. So things like data residency and stuff like that require that you have an on-premise version as well. So we offer this product basically in two forms. One is a cloud service and one is a on-premise service. And I'll explain a little bit about each of those and how they function. And as I mentioned as well, our SaaS offerings, they've picked up for our cloud ERP application. They have something that they call intelligent track and trace. And this does track and trace based upon transactions that are recorded in our blockchain platform. And then as well, our database team, of which I'm part of, by the way, the blockchain team is part of the database team. We have something that we're calling now a crypto secure database. So this is moving or leveraging some of blockchain technology in the Oracle core database. So as I mentioned, we have a cloud-based service. So there's a provisioning mechanism to be able to basically a control plane to be able to provision and monitor or provision and deploy cloud instances. We have an admin console that allows you to do such things as create peers, add channels, deploy chain code, all those sorts of lifecycle operations and stuff like that are done through our admin console, as well as monitoring. And then we also then have an on-premise version, which we call this day, the Oracle Blockchain Platform Enterprise Edition. And this is largely many of the same bits. It's a separate control plane though, because we can't use the OCI control plane in an on-premise offering. So we provide a VM that acts as the control plane, and then it's used to manage a set of VMs that are provided by the customer, and then we run Docker containers and Docker Swarm in that and deploy basically the same kind of elements. So our admin console, our API gateway, which I'll talk about in a minute, and as well as integration in with identity management, because that's something that doesn't come out of the box with Fabric. You need to integrate basically into an identity management system. Typically that's done through your Fabric CA. So we've integrated that with the Identity Cloud Service for our cloud offering, and for the on-premise offering, we support things like LDAP or AD for identity management. As I mentioned, we have also this intelligent track and trace. So this is pre-built SaaS applications that are leveraging our blockchain technology. And they're used for things like this to be able to get visibility into your supply chains, to be able to do things like tracking the shipments of goods, potentially cold items, so things that have to be refrigerated. So those are being monitored. All that stuff is being monitored then by our cloud-based services, but leveraging our blockchain to be able to record this information. And then finally, we have what we're calling the crypto secure database. So this is using blockchain technology in the database to create what we call blockchain tables. So a blockchain table is a table that can be insert only, and each row is chained and hashed to the next row as well. That the rows can be signed, cryptographically signed, so you know who made the modification or who inserted it. It's append only, so the records cannot be deleted. And it's part of our database, so standard SQL procedures are used, or statements are used to be able to update and add things to the blockchain tables. So a little bit about our cloud service. So at the center here, I show our blockchain cloud service. This could be the enterprise edition as well. As we say, we are based on Hyperledger Fabric. So we support smart contracts in Go, JavaScript, and Java. We have a library that we provide customers to be able to use, what we're calling fine-grained access control. So fine-grained access control is a way to be able to define a set of policies or access control lists that are stored on chain and are used to govern then the access to assets on the blockchain. So at the library we provide. We also then have integration in with some of our other services, so things like event management. We have the ability to be able to do what we call off-chain data sync. So we can automatically pump data into other environments like Oracle Data Warehouse. And I'll give a little bit of example about why we did that and what kind of use cases we have. So the advantages I say is that it's pre-assembled. You don't go grab a bunch of containers and try to build this yourself. It's open. We're based upon Hyperledger Fabric. We adhere to all the Fabric code standards and stuff. We do provide these plug and play integrations. Besides the ones with our SaaS offerings, we offer this API gateway. I'll get a little bit details of that in a second, but our API gateway provides a set of REST services to allow you to be able to interact with the blockchain network. This was something that we felt was absolutely necessary for integration purposes. Very few existing applications can make gRPC calls. They can easily make REST calls though. So REST tends to be the integration standard that is used. So we provide a proxy that basically takes REST requests and turns those into Fabric invocations, either queries or transaction submission, as well as things like administration and stuff like that. So we have a full set of REST services to be able to do that. It's enterprise grade. When you create the appropriate shape, whatever, we spread the instances around availability domains or across fault domains within the Oracle Cloud. And we also then do the DevOps. It's a fully managed service. So Oracle takes care of the patching, the management, the ensuring that the system is up and running, upgrades. So when we go from one version of Fabric to another version of Fabric, Oracle takes care of all those operations for you. So it makes it much easier for customers to be able to adopt blockchain as a service. As I say, the Enterprise Edition, this is essentially the same set of bits, they're just packaged in a different way. And the main difference, as I say, is that we can't use the OCI control plane, so we built our own control plane that runs in a VM, and then that control plane is used to manage the other VMs that are provided to it to deploy things such as your peers, your proxies, the console, all the various Hyperledger components and our components all get deployed then to this cluster of VMs that are provided to the control plane. So we provide, it's feature parity with the Oracle Blockchain Cloud Service. And so this is one of the things that we did this, as I say, because of things like data sovereignty issues and those sorts of things. So we do support, multiple cloud environments, multiple on-premise deployments. So you have your choice of where you want to run the various members of your organization or of your network, what kind of environment they want to run in. So it's easy to deploy, because I say it's all pre-assembled. You essentially answer 3 or 4 questions in the OCI console and wait a little bit, and your blockchain instance will be up and running. So it makes it really easy to experiment with this. As I say, because of the REST APIs and the client SDKs, we can integrate with many other systems, including third-party apps, on-premise apps, other applications as well. Which is really critical, by the way, because oftentimes blockchain is used as an integration mechanism between different systems of record. And so, having these kinds of integration capabilities makes a big difference. Identity management, that's something that, Fabric doesn't really provide. It doesn't provide an identity management solution. They have the Fabric CA, but as far as being able to, take care of the registration, enrollment, passwords, all that sort of stuff, typically you want to integrate in with some identity provider. So we allow, in the blockchain cloud service, we integrate with the identity cloud service from Oracle. So it's also, as I say, it's easy to manage and monitor. We provide a console, a set of interfaces that allow you to see what the activity is going on, to be able to monitor the state of the various nodes, to be able to, as well, that console is based upon a set of REST APIs. So all those APIs can be used by your own tooling. So you want to add a new peer, there's a REST command for that. You can do all those sorts of operations through the REST set of APIs. And as I say, as mentioned, that when we do deploy this with what we call enterprise shapes, because we do have a developer shape that you can deploy, but for most people, once they get past the development stage, they need to deploy and they want it enterprise ready, meaning it's got to be highly available, support things like disaster recovery and the like. Another thing that we've done as well is we've tried to make it easy to add new members. If you've ever built a blockchain network before out of Fabric, you have a lot of work that you have to do to be able to exchange things like MSP information, certificates, all that sort of stuff. That's all handled through our console. So we can integrate multiple instances of Fabric into a single Fabric network using our console. So we also have a growing portfolio of industry solutions. So we have a number of partners that are building on our platform, and I'll talk a little bit about those. Just basically an eye chart of logos and stuff like that. You'll see in a minute. Something that we're really I don't know, proud of, but really feel is a differentiator is that something we call the blockchain app builder. So the blockchain app builder is if you're familiar with Composer, the old Composer project in Fabric, that was sort of the idea, and that gave us the idea for this tool. It's fairly different though. Composer was built upon the idea that you created a model, and then from that model, you would then generate smart contracts and the like. In this case here, what we do is we start with what's called a specification file that defines your assets or tokens. And then we generate code and scaffold projects for you that you can then use something like VS Code to be able to edit, as well as a VS Code extension. And if I get a chance, I'll demo a little bit of that. We'll see if I've got time. And as well, something we've just recently added to the app builder is a support for tokens. So the idea here is that you can define in the specification file that some of the assets are tokens. And we follow the token taxonomy framework, TTF, which is an open standard for defining tokens. And then we implement basically all the methods that the token support. So is it mintable, burnable? Is it fungible or non-fungible? At the moment, we're only supporting fungible tokens, but the plans are to soon to be able to support non-fungible tokens as well. So the basic flow is, say, you start with this thing called a specification file. It's either a YAML or JSON file that defines the assets, their properties, things like the field requirements. So you can specify that a field is a string and it has to be no more than 15 characters. Or you can match it against a regular expression. So we have a variety of validation techniques that we can validate the field so that make sure that the data is correct before it gets entered into the blockchain. And as well as it describes sort of, the structure of all your assets. Field names and other properties and the like. From that, then we scaffold a project. So this creates a smart contract project that you can use to build your smart contract in either Go or in TypeScript. And so we take care of all the code generation. We generate the project artifacts, we do all that sort of work. And you basically have a ready to go smart contract. Typically, you're going to add custom methods because we generate CRUD methods. So you automatically get, create an asset, update, delete, read an asset. But typically you want more than that in your blockchain. So, things like in the marbles example is trade a marble or buy a marble or, any of those sorts of custom methods. You can define their interface in the spec file, but the actual implementation has to be provided by the developer. Once you've added your custom methods, you can then deploy this locally to a local Fabric instance that we start up and manage for you. And that's typically how customers test and get ready to go. And then once you've got your smart contract ready, you can, from the app builder, you can automatically deploy this then to an OBP network or any Fabric network for that matter. Yeah, it should be any Fabric network. We also support through the EVM. We can support Solidity Contracts. There's some instructions here on how to do that, but this is something we've had a number of customers asking about. How do I deal with Ethereum? How do I deal with Solidity? So you can then, as I say, you can compile and run your smart contracts and run those in our blockchain platform. And so you then from their tooling, you can do things like invoke the smart contract, but you can also then, because we expose all of the smart contract operations through a set of REST APIs, you can invoke all these through REST. So here's an example of being able to invoke a Solidity chain code and some arguments that can be passed to it using a curl command. So we also say it is a team sport. We like to say that Fabric is a team, or blockchain is a team sport, and we mean that in a couple different ways. One is clearly that typically you have multiple organizations, right? A single organization blockchain network is not particularly interesting, although we have a number of customers who are doing that. But we typically see where there are multiple organizations and there are probably multiple instances of Fabric running, and even different, under different environments. So one of the projects we did with a company called Mipasa. So this is a blockchain network that's deployed across Oracle, IBM, and Microsoft Azure nodes. And as well, we have another customer, CargoSmart, who's tested this and operates with LA Cloud's blockchain as a service. So we also support DAML through third-party integration. So we can run DAML smart contracts and Solidity as well, as I mentioned before, using the EVM. As well, we have another partner called Overledger. And so Overledger provides essentially as a way to be able to do cross-ledger transaction integration. So this would be the ability to be able to do things across OBP, Corda, Quorum, other blockchain networks. So this is a partner of ours because we see a lot of customers that are interested in this, being able to get cross-blockchain interaction. Real quickly here, some examples of what we have in sort of production or whatever. So we have a large number of customers that are doing a variety of things. So we have a lot in the financial services, things like know your customer applications, point of sale for eKYC. So a number of different things in the financial services area. In the supply chain area, we have a number of customers. Hyperledger, you may have heard of. They track the provenance of diamonds from the time they're mined until the time they're sold in a retail store. Abbott is using it for COVID-19 test results. So we're seeing this in a number of different areas. And then as well, we've got things like we're doing for certificate of origin. I think CargoSmart is building their global business shipping network. Based upon Hyperledger Fabric and our instances. Certified origin tracks olive oil from the time that the olives are harvested, pressed, the processed and bottled and delivered to the store. Circular is doing the same thing for cobalt batteries and the like. So you see, we have this is only a small fraction of the customers we have and the kinds of things that they're using our blockchain platform for. As well, we also have a set of partners. So industry partners here that are building their applications on our platform. So Sedema is using this for doing what's called non-performing loans. So what do you deal with a non-performing loan? So they create a marketplace for other financial institutions to be able to buy these non-performing loans. We have a number of customers who are using this for KYC related applications. A number of, I should say, partners. As well, we have, as I mentioned, like Circulars managing and taking care of conflict minerals, track and trace sort of operations. So you get a feel for them. I'm not going to go through all the details in all these, but we have a large number of partners, largely because of Fabric's popularity. So a lot of these customers are built on Fabric, which means they should run without a problem in our platform. So what I really want to get into is the major purpose of this talk is to talk about sort of the updates that we've made and what's going on within Oracle around Fabric. So as I already mentioned this, a duplicate slide. Sorry about that. Go through this. So some of the things that we've taken care of are things like the provisioning. So as I say, we take care of provisioning in a cloud environment or as well in an on-premise environment by providing a local control plane. In the Oracle Cloud, this is all done through the normal OCI cloud management console. So you can create containers, you can create your blockchain instances there. And I would say we automatically take care of starting up the instances, spreading the instances across availability and fault domains to ensure things like high availability and disaster recovery. We manage it, which is a really, critical point. If you've ever managed a Fabric network, it's a lot of work, keeping up with patches, making changes, upgrades, especially, recovering from certain kinds of failures and stuff like that. We provide tools to be able to help with that. An example of that might be is that you end up with non-deterministic chain code that you didn't realize. And that doesn't necessarily show up right away until your peers start to result with different results. So we have a mechanism to basically be able to detect some of that and basically be able to rebuild the ledger once the non-determinism has been removed. We also take care of then, taking backups of the configuration. We provide backups of the ledger so we can recover from failures. We have integration, as I mentioned, with the identity management. So that's already taken care of. We do provide an audit. We have this ability to do the crypto hash integrity validation. So we can go through and validate to make sure that your world state is consistent with the blocks in the ledger. We provide this bidirectional API gateway. So that's what I was mentioning before, what we call a REST proxy. So this supports essentially a set of REST calls to be able to interact with your Fabric network. It also allows things like event notification. So you can specify that you want to get a callback when an event is generated by a Fabric chain code. So this makes it really easy to integrate in with other systems. It also makes it easy to test. You can simply use a curl command and test against your REST proxy. The console takes care of, say, many of the administrative tasks. So when you want to see what the performance is like, you want to examine the ledger, you want to add new peers, deploy chain codes, all that stuff can all be done through our console. The app builder I'll get more into. We're going to talk a little bit about that. The most recent thing that we've added here, as I say, is the token support. So this is a completely new set of features that we've added to Oracle the app builder, blockchain app builder. And we think there's going to be a lot of interest in this because there's huge interest in tokens right now. And we've also done some optimizations around that. So I'll talk a little bit about how we handle tokens in an environment where we use a balance base as opposed to I'll think of the term. I've gotten it anyway. Something else we did very early on is we replaced the Ledger DB and the Couch DB options for world state. We replaced those with Berkeley DB. And the reason we did that is that Berkeley DB has a SQLite driver that it can be used on top of BDB. And so this means that you can do full SQL queries inside your chain code. Which is much more powerful than the Couch DB query language. Although we do support the Couch query language, we transform that into a SQL statement basically, and then return the results as Couch would return them. This is significantly faster than Couch because like level DB, Berkeley DB is a in-memory basically database. So it's not a client server database like Couch is. I know the caching capability they added for Couch has helped some, but we still get far better performance for many things using Berkeley DB. And in some cases, we get dramatically better performance because with full SQL, we can push computations down into the database. So as an example, let's say you wanted to get the average account balance for a bunch of accounts. You can do that in a single SQL statement with one round trip to the database. Whereas if you did this with something like Couch or Level DB, you'd have to go and get every one of those accounts and do the average calculation yourself, which would result in a gigantic read-write set potentially, and much, much longer to execute. Finally, another thing that we do is we support what we're calling the rich history database. So what we do is inside the peer, we siphon off your transactions and store that information into an Oracle database. Then we maintain two things there. We maintain basically the transaction records themselves, and we maintain the state. So you can go back and do rich queries using standard SQL against the Oracle database instance to be able to do queries about the state of the database as well as about the transaction history. And this includes the full transaction history. It's not like the transaction history that's provided by Fabric, which just provides you an index into the ledger to be able to get something. This returns the actual transaction information. So this is an example. This is the OCI console we see here. So we're under the developer services. You select the blockchain platform. We take care then of configuring all the VMs. We set up the block storage for you. We define your load balancers. We set up a front end security service. We allow you up to 16 nodes per instance. That's probably an artificial limit, but it's what we're supporting right now. We can create new channels. We can add members to channels. All that stuff is done through the admin console that's provided. And then as well, so the OCI takes care of all the deployment. So it's the control plane, but the data plane is where we have all the administration operations for the various components. So here's a picture of the console up in the upper right here. So it's saying that the instance is healthy, what the utilization looks like, what kind of activity is going on. And you can drill down into your channels, your peers, ordering services, nodes, and other organizations that you may have joined into your network. So that gives you a nice GUI interface to be able to manage and monitor your blockchain network. So you can bring nodes up and down. You can configure your channels, your peers. You can add policies. Do all this sort of work all through the console. We also take care of the smart contract lifecycle management. So we can deploy smart contract packages from the console to take care of the things like defining your private data collections and mapping transient data and the like. And I'm going to say we also provided this sort of the monitoring and troubleshooting. So you can view your topology, you can see the status of all of your components. We collect operational metrics, so you can see what kind of transaction history you're getting, what kind of volume you're getting, and as well the ability to be able to drill down into blocks and specific transactions within the ledger. So the rich query support, I already mentioned a little bit about this. This is, say, there's a replacement for Couch. So we can use full SQL select statement capabilities. And so this gives us the speed of LevelDB, but gives us the query capability of CouchDB, or much more than the CouchDB, actually. Another thing that this provides us as well is that BDB supports, through the SQLite interface, provides record level locking. And so we can do concurrent endorsements and commits at the same time. Normally Fabric locks the database and does only commits or endorsements. It doesn't do them simultaneously. We can interleave these so we get better performance, lower latency, things like that. Like I say, so this ability to do select statements, you can do an awful lot in a select statement, put it that way. And that's all supported out of the box. And as I say, we also then we'll take the Couch query syntax as well, provide that, and then we translate that into SQL statement. Another huge benefit here to what we've done is that we revalidate the query at commit time. So if you use a CouchDB as an example, and you make a query and you use those results in a transaction for making a modification, you suffer the possibility of dirty reads because the query is not re-executed at commit time. We re-execute the query at commit time, and so we can verify that the query returned the exact same results. We basically compute a Merkle tree and get a hash of that. So we get the ability to be able to do rich queries with using SQL statements, and as well this ability to prevent phantom reads or other issues associated with not having the query revalidated. Rich history database. This, as I mentioned before, this is where we automatically siphon off data from the peer into an Oracle database. So we define a schema that is used inside the database. Once that schema is created, then we will update the Oracle database, history database, at the same time that basically the information is being committed inside the peer. So we model this using JSON in the Oracle database. And what that does, though, is this makes us available for other tools. So you can use things like analytics tools and stuff like that to be able to analyze your blockchain transactions, or some other uses, and I'll share those in a minute. John, I see we've got some stuff in the chat. Any questions that we should address?
Yeah, Todd, you're doing such a great job on your presentation and covering a lot of ground. It's
Okay.
up to you if you want to, kind of interject right now, or if you'd like to kind of finish out this and then we can go to the Q&A session, whatever you prefer.
Let me finish up that's on the risk history. I've just got a couple examples here, and then we'll take a break for some questions and then continue. So
okay, great.
So as I say, what happens here is when a block goes to get committed, the peer that's associated with this, that receives this and has been configured for this rich history, it essentially then pumps that data into an Oracle database instance. That could be autonomous data warehouse, any Oracle database instance, essentially. And then at that point, what happens is, we pump all this stuff transparently. So now inside the Oracle database, we have the ledger as well as the state database, because we do the same thing. We maintain that state information in the Oracle database, just as it would be maintained in the state DB that the peer is maintaining. So that once you've got this data here, you can do visualizations, you can run analytics, you can export this to some other application. It gives you essentially a copy of the data without having to do things like query operations. Now, it may lag a little bit because we commit this asynchronously against the database. So it may lag behind under high volume, but we have a number of customers who are using this for like read queries. So instead of performing a query operation against the blockchain, they simply hit the Oracle database instance and get the information. So analytics, you can, as I say, now that it's in a relational database, there are tons of tools to be able to analyze this data. High volume reads, this was one of the cases of one of our customers where they do a significant volume of reads, and they don't need all those to occur on the blockchain itself. They're happy to have a copy of that data that they can read against. So you can also then compile this and consolidate this from other systems or other systems that you interact with to be able to get a full view of your transactions. Let me break here then. So why don't we hit a couple of the questions, John? Let's see.
Okay, Todd, let's jump in, and I'm not going to take them in, the way they were put in. I'm going to take them in kind of a interesting order here. So
Okay, go ahead.
they were talking about hybrid cloud versus, let's say, on-premise, or, let's say blockchain as a service cloud. Do you support hybrid cloud for any of the blockchain service that you offer?
Well, I'm not sure what they mean by hybrid cloud. We do support, we've shown that we can integrate in with, other blockchain cloud services that are built on Fabric. As well, you can integrate in with the on-premise version of Oracle Blockchain Platform Enterprise Edition. So
I think maybe they were just looking at it more in kind of the VMware style of hybrid. But that makes sense, Todd. Okay, let's ask another question here. Jayjun has a question about, does it require an upgrade from always free resource subscription?
Okay, that's a good question. Unfortunately, our blockchain platform, because of the compute resources that it requires, is not available as a always free service. You can get a 30-day free trial, and then you can migrate that trial to a paid license, or a paid service offering. But we don't have this available as a free offering at the moment.
Okay, perfect. And then there was another question here about explaining more about Overledger. And my question there is, Overledger is blockchain interoperability. And are you doing anything with the Hyperledger Cactus framework as well?
Yeah, we've been monitoring Cactus. We've not been doing anything with it at the moment. Overledger is handling this at a sort of a lot higher level, I guess. And we're basically relying upon them to provide this interoperability with things like Ethereum or Corda or the like. So, and I don't know a ton about their offering, I will have to admit. So, but I know we have customers who are using this to be able to integrate our blockchain platform with other blockchain networks.
Okay, perfect. And then Umit has another question here, but he wants to separate his chain code smart contract app logic and executables from the blockchain database that he's running on. Is that possible?
The blockchain database, I'm not sure. You mean,
Yeah, we can take Umit off of mute here.
Yeah, if you want to explain Umit, that'd be great.
Yeah, hi. Can you guys hear me?
Yeah.
Yes, you sound great.
Oh, hi. Thank you. So I was just wondering if it would be possible to separate the business logic, the smart contract automation script, essentially, from where the Oracle blockchain runs. So you can have. We don't want to deal with the Oracle maintenance. Like, this is a great platform, so we want to maintain that, but we want to keep the smart contract logic and the affiliated data in our own on-premise database. So there has to be some way of port communication over some TCP port connecting to the Oracle database, where you can leverage the blocks running on the Oracle cloud. Is this kind of setup, hybrid setup, possible? So I can have full control over smart contract.
Well, you have full control over the smart contract. That's just standard Fabric behavior. The unique part here that we provide, as I say, is this sort of data pump into the Oracle database. So the Fabric doesn't use, well, our version of Fabric says it doesn't use a client server database. So you can't run your smart contract in the cloud and have it use a database that's in your data center, right?
Oh, you can't. Okay.
That would be considered a poor practice, because for your smart contract to execute against that, everybody else that executes that smart contract would have to have access to your Oracle database. You probably don't want that if it's a multi-organization network.
I see. Okay. Thank you.
But what you could do, though, as I say, is you could set it up such that it runs in the cloud, and then it pumps the data into your Oracle database, which then you could use for, for, as I say, for queries or for analytics and the like.
Would in that scenario, can my smart contract query the Oracle database from a public cloud?
You could do that, but that would be, as I say, a poor practice. Generally, unless your Oracle database is accessible to every member, they won't be able to access that data. So their copies of the smart contract won't execute.
I see. So essentially, the smart contract runs also in the Oracle clouds. In the way you described this presentation.
It runs in what we call an instance. So that may be either in the cloud, or if you're running the enterprise edition, it could be on premise.
Okay, got it. Thank you so much. It's a great presentation.
Thanks.
Okay, Todd, I'm going to jump over to Jim Zhang. He's got his hand up. So Jim, if you want to come off mute and ask the question, that'd be great.
Oh yeah, thanks, John. I just want to follow up on that question from Umit. I'm pretty sure he's referring to the external chain code model that's available in Fabric 2.0, where chain code doesn't have to be deployed to the peer at all. It can be run somewhere else, and then just you be provided the endpoint URL to the chain code spec on the peer to be deployed that way.
Right. That's a 2.2 feature. We're not supporting that just yet. We are offering support for 2.2, I think, next month. But we don't have at the moment a means to be able to support external smart contracts. That's in our plan, but that's not present at the moment. All right, why don't I continue, and we'll take some of these other questions in a minute.
Perfect, Todd. Sounds great.
Okay.
Everyone
So,
just hold your questions and we'll get to you.
So another thing that we encountered was that customers want better control over the access to the assets to the they're storing in their blockchain. So we provide what we're calling a fine-grained access control list. So this is a library of smart contract functions that can be used to maintain access control lists. And these access control lists can be applied to virtually to almost anything. They can be applied to the invocation of an operation on your smart contract. They can be used to control access to specific assets. And all this stuff is maintained in the ledger. So you have, complete visibility of the kinds of access control lists and who can do what and who can't do things. So it is stored in the world state database. And so you use these functions inside your smart contract to be able to manage the access to the assets that your smart contract is using. So App Builder, this is what I want to get a bit into. So this is our console showing up our development tools. So we provide, as part of it, we provide a set of examples. We provide tools to be able to interact with your smart contract. So a lot of that's done through either the App Builder Visual Studio Code extension. So we have an extension for VS Code that you can use that supports our App Builder model of scaffolding a project from an asset definition and then deploying that, as well as the command line interface. And so we support we support a number of samples as well. So we have a copy of the FabCar and Marbles examples, and many of these you can actually interact with through our console. So these can be deployed into your network, and then we provide a simple little UI in our console here. And that's mostly just to be able to test and try things out and get a feel for how things work. So, as I say, we've made a number of enhancements around, the SQL queries. So we believe that really provides a lot of value to the developers. Being able to stream it into, a database for analytics. We make it really easy to onboard low-tech members. So there's an ability within our platform to be able to onboard client organizations that don't have their own infrastructure. So they rely upon the infrastructure that's by one of the other members of the organization of the network, and then these are what we call client only, and that helps in a lot of cases where not every member wants to bring their own infrastructure and bring their own compute resources, basically, to manage an instance. I already talked about access control lists, bidirectional gateway, things like that. So the enterprise edition, I talked a little bit about this. It's a software appliance. It comes as a VM, as a VM image. It can run in VirtualBox or Oracle Linux or VMware. So you can deploy the control plane VM, and then you deploy more copies of that VM as workers that are going to be used to deploy your Fabric instances and your Fabric components. And it supports a variety of different shapes. And so typically what happens is if you want an enterprise, then you create 3 + 1 VM. So 3 VMs for peers and CAs and the like, and 1 VM for smart contract deployment. So this shows the platform manager VM. That's our control plane, so we can manage instances, locally that you provide the VMs. It could be in the data center. Basically, all we need is access to the connection between our container and our VM and a network connection to the instance VM, which is where the data plane runs. So this is showing a little bit more into our app builder. So you can see over on the right here, this is showing some asset definition. So in the middle here is the asset is called a distributor. It's got a property, so it's got its ID. There's a bunch of properties on the properties or assets, properties on the asset fields. So you have things like, this has got products to be shipped. It's a number. Product shipped is also a number, but it's got a minimum value of 3. So you can see there's a variety of different validations here that can be provided, as well as different data types that are supported for the various properties of an asset. So from this file, then you can basically then scaffold a project. So this is all supported within VS Code. We also provide a command line interface to provide these same operations. Then from this tool as well, we can then deploy to a Hyperledger Fabric local instance, or we can deploy to a cloud instance. All that's supported from the Visual Studio Code extension. If you're running locally, you can even do a line-by-line level debugging of your smart contract. We don't support that when deployed to the cloud, only to do a local instance at the moment. Yeah. So say we do from the scaffold or from the specification file, we then generate the code necessary. So we use a model controller pattern. So you end up with a model that defines all the fields, and then a controller file that defines all the behaviors. So we create behaviors like the CRUD operations, and that's also in the controller file is where your custom methods would go. So your actual business logic that does more than just CRUD operations. We take care of the persistence of it. So you treat these things as objects. So these assets, when you in your smart contract, you simply say, I want to get this asset by its ID. You don't get back a JSON or whatever. You get back an actual object in that chain code language. So either a Go object or a TypeScript object. And then, so that's what you deal with. And then when you're done with updating the object, you can then say, I want to update it in the database. We take care of that persistence. So we take care of the model mapping into the chain, into the state database key value store. Something to say we recently added, it was tokenization support. So here's an example of an asset. It's called My Red Coin. It's a type of token. It's fungible and it's fractional. And it's well divisible. So these are all operations that can be performed on this token, and we provide all the code to implement all these operations. So you can also add your own custom methods again for the tokens, and you can mix things with tokens as well as with just normal assets that aren't tokens. So this is the normal flow, is that, for a number of things that are done by our SDK, token SDK, we take care of, the sort of setup, initialization, creating accounts and add roles. So there are all set of methods and operations to do that. This is typically done by the administrator. And then there's the operations, like I mentioned before. So minting, creating new tokens, transferring those tokens, burning them to destroy them. All that stuff is handled by code that we generate or part of our library. Something that we've done as well is we've updated the chain code operation and commit validation code to support the ability to be able to avoid MVCC errors. So when you deal with tokens, oftentimes tokens are accessed multiple times in a block, and typically in Fabric that creates an MVCC error. What we've done is we've allowed your tokens to have numeric fields that we identify. And then what we do is when you create operations against those, we create and store, instead of the actual value, we store a delta as part of the read-write set. And so that means that we can support the modifications to a particular token value multiple times in a single block. So we can then make sure that it never goes negative if that's a requirement, but we also want to make sure at the end of the block that it meets all the standard requirements for that token. but we can do, as I say, multiple updates to a single token because we record, instead of the absolute value, we record the delta between the previous value and the new value. So that can be applied in any order. So this is one thing we're doing to help improve the performance for token-based applications, because we found a lot of customers were encountering, when they tried to do this sort of stuff, they were encountering MVCC errors. This is just showing again the development, our set of samples here, and for these samples here, all of these, then you can install and instantiate the chain code, and then as well you can invoke it. So we create a little simple UI for doing that. So here's an example. You can token actions. You can say I want to issue tokens, what channel that chain code was on, and then when you do this, we also then check and collect your queries and stuff like that, or the parameter values and things. So we provide a little screen to be able to capture that information. So where we're going is more work on tokenization, especially supporting for NFTs. So that's one of our things on our next planned release. We're trying to say what we're trying to do is make the developer and administrator's life easy. So the more things we can do to make it easier for them to be able to integrate, to be able to write their chain and test their chain code, to be able to make sure that their networks are deployed properly and the like, those are the things that we sort of focus on. So on the development side, also on the operations side, one of the things we're looking at is to provide something like the operation system chain code that's been proposed. So we've been talking to that team a little bit. We would like to incorporate that into our console. So you could add new organizations, remove organizations, and do all that on chain, as opposed to the current mechanism, which is effectively, a whole lot of out-of-band communication. And then as well, we are upgrading to Fabric 2.2. That should be done this month or next. Another thing we're looking at is we have customers who want to store large state databases. We have one customer right now when a single transaction contains something like 260 megabytes. Not sure that's a great idea, but customers are requesting some of this sort of stuff. So one of the things we're looking at is to overcome the limitations of the in-memory databases like LevelDB, or in the case of us with the BDB, Berkeley DB. When they get really large, performance suffers dramatically, whereas with Oracle database, it doesn't. You take an upfront hit for the round trip to the Oracle database, but it scales much better for large databases, as well for a large number of concurrent users. So that's something we're looking at, is providing an alternative to BDB, is to use Oracle database for state database. We're looking at, say, ordering services. So we've got some group within Oracle that's looking at BFT consensus algorithms, particularly Smart BFT or Libre BFT, and trying to do a formal proof on that to verify that it's provably correct. So these are sort of the areas that we're working on, and I want to stop here so we can take the final set of questions then. So. Oh,
yeah, this is great information, Todd. And let's just go, and probably the easiest thing is, I think Jim has a couple of questions here for you. So Jim, maybe you want to come up and just ask your couple of questions about the Fabric network and also the UTXO model.
Yeah, sure. Thanks, John. Thanks, Todd, for the great information. First question I had is, can I have some nodes running in the cloud with OBP and other nodes running on-prem within the same Fabric network?
Yes, absolutely.
Okay,
perfect.
Cool. Thanks. My second question is the app builder, when it generates for non-fungible token or fungible token, is it based on account balance model or UTXO model?
We're currently out, well, for our fungible tokens right now, we're based on a balance model. And that's why I was mentioning that we did this enhancement to avoid the MVCC errors.
Yep.
So that's the big issue with the balance model, right? In Fabric, is that it's not very scalable. It's not scalable, right? What we've done basically allows it to be scalable, because we allow now multiple transactions executing against the same token in the same block.
Yeah, basically you will avoid having to read it first and then set the value. Okay, agreed.
Well, what we store is we store a delta.
Yeah.
right? So that way, at the end of the block, we just make sure that all the deltas end up with a value that's reasonable.
Thanks.
Right, so
that was all my questions.
Okay.
Perfect. And the other one I want to kind of just touch base on, Todd, I know you've done a great job of going through this, but Gopi had asked a question about, the versions of Hyperledger Fabric that are supported. And so let's just clarify that for everyone on the call here. What's currently supported today and the roadmap, what's going to be supported in about a month.
Yeah, so 1.47 is what we're currently supporting, and I don't remember which dot release of that, 147 something.
Sure.
And as I say, we take care of. So if you started with 141 or whatever when we first started the service, or actually we started with before that I don't remember what the initial version was, but we take care of then upgrading that for you on your behalf. And as far as 2.x release, we're planning that I think the release is next month. So we'll be supporting 2.2.4, I think is what it is.
Hello, Todd, this is Gopi. Thanks for that information. Yeah, I do understand you are going to do it behind the scenes as the upgrades, and that would have impact on refactoring the code, because there are going to be significant improvements in 2.2. That's why my question was to know when it's being done. That way, customers could be aware of when they could plan for a code enhancement on that.
Yeah, as I say, doing the upgrades, we will take care of that automatically, although there will be some things because of changes in Fabric where there may be changes that have to be taken place in your smart contract. There's not a lot we can do about that. And especially if you want to make use of obviously any new 2.2 features, you'd have to make changes. But otherwise, if the smart contract will run under 2.2, we will take care of the upgrade and things will just run just fine. So we've been testing that extensively. We want to make sure that we don't break a whole lot of cloud instances. But yeah, so that's to say that's a huge advantage we believe is that you don't have to worry about the upgrades. We take care of that to the extent that we can.
That's great to hear that. So if we have that modeling language or scripting language that we have, that takes care of generating the right code based on the version. Am I interpreting it correctly?
No. So well, a couple things. If you're using App Builder, and when we do the upgrade there, we'll provide upgrades to App Builder and to the libraries that it uses and the like to be able to support the new version. And you'll basically go back into App Builder and say, I want to upgrade my chain code to use this new stuff. And then it will get rebuilt inside of App Builder. But as I say, there are some changes that have been made that we can't take care of inside of the smart contract that would have to be made in some scenarios.
Got it. Yeah, that's fair enough. Yeah.
Okay.
Thank you. And just one other question. I have some interesting information I saw about the interoperability. You have one for Ethereum and with other blockchain frameworks. Any time frame on when the interoperability would be available with? You mentioned someone with Ethereum, which I could see that, about the other blockchain frameworks also. Yeah,
that's where Overledger comes in. So Overledger, as I say, provides a solution that allows you to be able to integrate different blockchain networks. And they support our Fabric instances. So that's the extent of, I guess I would say, the interoperability at the moment between different ones. As you mentioned already, Ethereum, obviously, we can run Solidity smart contracts and stuff like that.
Yeah. I got it. Thanks. I don't have much knowledge on Overledger. So is that another product or another framework from Oracle?
I'm sorry, what is it called?
You mentioned Overledger.
Overledger, no, that's a partner of ours.
Oh, partner. Okay, got it. Yeah, thank you.
Any other questions? There was
Yeah,
a
we
bunch
have
of stuff in
another.
chat.
Yeah, Jordan, if you want to come off mute and ask your questions, that'd be great.
Yeah, sure. Thanks, Todd, for a great presentation. Just two questions. One question is about identity support. And so I'm wondering if you have a plan for supporting DID-based identity solutions like Hyperledger Indy.
That's a really great question. And we've been tracking DIDs for a while. And we do want to support them. We don't have that yet. Okay. But we have some ideas about how we want to support that. So as I say, Fabric doesn't provide any identity management on its own, right? Mm-hmm. So you need something to be able to, with your CA, you typically need integration with some kind of identity management system. So say we did it with IDCS and LDAP for our EE and Microsoft AD. And we're looking at what we can do with DIDs. So we have not tried it. I think we've got some customers though who've tried using Indy with Fabric, but we don't have that support yet. But clearly, that's something that we want to look at. So,
okay. Any time frame?
Earliest would be late next year. It'll be a little while.
Okay. All right. And then I had a second question with regards to the tokenization support and supporting tokens. Are you supporting any particular wallets? And if so, which ones?
No, we're not supporting wallets at all. So if you want to do something along that lines to be able to, manage your own certificates and stuff like that, you can, but we're not providing anything along that lines. We're basically using the existing identity management to be able to say who can do what. So you get a set of roles to be able to perform things. And so like if you're an admin role in the identity management system, then you'll get admin capabilities. If you have that particular role, then you'll be able to do admin functions against the tokens. But no, we don't have any wallet integration at the moment.
Okay. So I guess what about if you're working with like verifiable credentials? Is there any support for verifiable credentials as a tokenization solution?
Not yet.
Okay. All right. Thank you.
Okay, Todd, we're coming up at the top of the hour here, but I'm going to jump over to Ron. If you want to come off mute and ask your question about contracts and pricing. I don't know if Ron's still with us here.
So what the cost is, and also do enter and contract between me as a developer and Oracle.
I'm sorry, I didn't hear the question. Could you ask that one more time?
What is the cost of? Do you have some pricing information, and is it necessary to enter a contract between myself and Oracle?
No, it's just another cloud service. So you use cloud credits, and it's based upon the number of OCPUs basically that you have. So, it's our normal cloud-based pricing, and it's just offers other. So there's no contract that I'm aware of that you have to do, but you after the 30-day free trial, you would need to purchase cloud credits then to be able to continue using your instance.
Do you have some information? I mean, I've had contracts with Oracle in the past. Do you have any contract information or any credit information on what that price would actually be?
Yeah, if you go to, where's that information? That should be, if you go to this where it says try OBP and Oracle Cloud free tier, you should be able to get the information, the pricing there. It turns out that for like a small configuration, it's several $100s a month, something like that. So, I mean, it's not particularly expensive, but it also depends upon the size of your deployment. I mean, we have deployments that go to extra large, which means 24 OCPUs. And that's obviously going to cost quite a bit more than what we call an enterprise small instance. So I don't have those numbers off the top of my head, but that should be available at that link here about blockchain cloud platform.
Thank you.
Mm-hmm.
Okay, and Todd, I just had one other question here. I was on another presentation by Mark from Oracle, and he was talking about a collaboration you're doing with Zua around NFTs. Is that going to be one of your partners going forward in the NFT space?
Yeah, so Zua offers an NFT solution based upon our platform. So they're a partner of ours, and that's who we're recommending right now for NFTs. But we also know customers want to do NFT development and normal asset development and the like. So that's why we're putting this stuff into App Builder. But Zua right now is our go-to partner for NFTs. Okay.
Okay, well, I really appreciate everyone's time this morning. I want to kind of keep it right to our hour time frame here. Todd, exceptional presentation. I say that any shop that really is familiar with Oracle and has that installed would greatly benefit from the Oracle blockchain platform. And if there's any contact information you want to offer, Todd, for them to get a hold of you if they have questions.
Sure.
Follow-up questions, that'd be great.
It's just my first name dot last name. So todd.little@oracle.com. Okay.
Perfect. Okay, everyone. Well, thank you very much for joining this session. And we look forward to the follow-up with Todd. And feel free to reach out to him with any follow-up questions. Thanks.
All right, thank you.
Thanks, Todd. Thanks,